Hello guys, I am Sumit Kumar Das and welcome back to SK Neuron. You are watching the next episode in our LangChain course playlist, and today we'll be deep diving into one of the most fundamental concepts in LangChain, that is messages. In the last video, we walked through how to interact with different types of LLMs in LangChain, including OpenAI, Gemini, and few of the open source free models as well. If you had missed it, I recommend checking it out to get the full context before diving into today's topic. If you are building any AI application with LangChain, understanding messages is absolutely critical. So let's dive in.
So, what exactly are messages in the LangChain? You can think of messages as the building blocks of any conversation with an AI model. They are the fundamental unit of context that carries everything your model needs to understand what's happening in the conversation. And that is the beautiful thing about LangChain, that it is provides a standard message type. It provides you a standard type that work across all models. For example, you have models from OpenAI, or you have models from Gemini, or be it models from any AWS based or any open source models. You no need to worry about the different formats this each model need to pass upon, because OpenAI has its own format of taking the input from user. Gemini has its own input format. But here, via LangChain message, you no need to worry about those format types. You no need to worry about those format types, and you no need to worry which models have which type. This gives you a standard interface so that every model can work with this same type of format. Now let's see what exactly is there inside a message. Each LangChain message mostly has three main components. First one is role. What do you mean by role? It identifies who is speaking or who is giving the instructions. Is it system giving the instructions? Is it user asking a question? Or is it AI responding? It identifies the speaker in the whole conversations. And next is our content. Second most important part here is the content. This is the actual payload, and it can be text, it can be images, it can be audio, it can even be documents. Pretty cool, right? We'll see in details what are the roles, what are contents, what are their types, and even we'll see the code demonstration of it also. And the final core component of it is the metadata. This is like your optional or extra data which gives or which helps you understanding about those messages better, or helping identify those messages. For example, having message ID, which is the unique identifier for each message, or having some extra response information, be it about token uses, be it about throughput uses, or be it about timestamp. There's some of the extra message or extra information being passed with your standard question and answers, because you are asking the question to model and model is responding back. But in this when you have a lot of conversations throughout the over a period, then you will be confused about when I got that message or who is speaking about that message. For that you need metadata. So first of all, let's focus on role for a second. There are four main roles you need to know in LangChain. First is system role. First is system role. This tells your AI model how to behave. I mean, it has nothing to do what you ask or what model is giving. This is like you are telling your model how to behave, like some additional context. Most of the model does not support this, but majority of the popular models, be it OpenAI or Anthropic or Gemini, they support this, and this is incredibly powerful for whichever the model it is available. We'll understand about the system role in detail, but you can think like this. Here you are telling the AI model in starting how to behave. The second role is user role, and this is pretty straightforward, right? It represents input from the person who is using your LLM application. And third role is as assistant. What is the third role? That is assistant. Assistant role means these are the AI response. It can include text, or it even can include request to use tools. Tools means external functions or for any specific requirement you have. Okay. Then you have one of the final role that is called as tool. Whenever your LLM or your AI system needs to call a external or need to process some of the external data via some of the external function which LLM alone cannot do, then you need to do the tool calling. And once this tool calling is done, it has to give the result back to the LLM to process that result. For example, I want to know the today's or current temperature of Delhi. LLM is trained on the past data. It cannot know the current temperature of Delhi. So it needs to go to web search, or needs to go to any web browser. It needs to do the search for the temperature of Delhi at this particular date and time. It will get and it will provide back that result to the LLM, and LLM will take that result and will process it. That is what tool calling is all about, right? So this is all about the major roles available in the LangChain message. Now let's understand the content part a little bit more. Currently, most of the chat models supports text as the primary content type. Okay, so they support text as the primary content, but there are still many models. You've been heard about multimodal LMs. What they support? They also support multimodal data. That can be any your image, that can be your video, that can be any external file, that can be your audio. These are the any input other than the form of text. Those are called the multimodal data. And many popular chat providers, be it OpenAI or Gemini or many open source Hugging Face kind of model, they support it. Content you can think like payload of the data. It is payload of data. And LangChain models accept the content in different ways. If it is only text, they can accept the content in string format or simple text format. Or it can be a list of content blocks. It can be a list of content blocks, but it will be specific to provider. For example, for OpenAI, we are providing in the OpenAI specific format. For the Anthropic, we are providing in Anthropic specific format. So either you can provide simple text to any of the model, because every model, the basic requirement is are supporting the text. But you, if you need, you can also provide them in their requirement, because OpenAI has its own format. You can provide it that also. That is available, but that is not the mandatory things. That is one of the options. Okay, and the final or the most important is LangChain standard content block. Okay, what does it do? It supports whatever the chat model you have, whatever kind of model you have. Every model will support this kind of format. So this is a single interface. Okay, be it chat Anthropic, chat OpenAI, so everyone will accept the LangChain standard content block. So either you can provide through simple text, or you can provide a specific format, be it, I mean, model specific format, or you can go through the LangChain standard content block format. That is the standard interface for all the chat models available, which are being available in the LangChain integrations. Okay. Now, so we have discussed about the role, we have discussed about the content. Coming to the metadata, so there are different metadata available. First one is, as I told, is ID. This is the like unique identifier for the message. So you did 10 conversations. You want to find the second conversations, or you want to go to the fifth conversations. So you need to have a specific ID for that, to go to a particular set of conversation. Then each message will have some name. You can provide some name, like you can think like to different entities or different speakers with the same role. Okay, for example, first person A has been spoken, second message 1 has been spoken by person A, second message has been spoken by person B, then again third message spoken by person A. You are doing a multi-person conversation. Then how will distinguish between them? Like, so that you can give some name. I will give some 1A, 2B, 3A, or with person name, or some entities if you have. Again, it depends on which models are supporting this or not, but this is kind of metadata available. Okay, then you have, obviously you will have the tool call. Whichever the model, whenever any model request to any tool call, you can see their information, which tool call has been made, what is the name of the tool call, what is the description of that tool, what exactly that tool does. So you can find all this information in this tool call metadata. And then you will have some other specific section where you can find the information about the response. For example, token uses, what is the input token, what is the output token, what is the streaming tokens, how much token has been used for reasoning, or like for example timestamp. So these are some of the other metadata which you can find also in the message section. Okay, now let's understand what are the different types of messages available in the LangChain. Now let's see what are the different types of messages. So first message is system message. Okay, and this system message is correspond to the when role is system. When your role will be system, the message associated with that will be called as system message. We will see how you, so as I told, right, role is different. Role is one of the component of the message. So whenever the role is system, that particular message is called a system message. System message, I mean, you can think this like the initial set of instructions that primes the model's behavior. For example, you have to set the tone, like I want the whole conversation about the financial, or I want this conversation should go on the healthcare domain. So every time you no need to tell that this is I'm asking about the healthcare domain, this is I'm asking about the financial domain. I mean, it is not mandatory, but it will always help the model to understand what is the tone or what is the context of your conversation. It is like giving additional context or instructing the model to adapt as a specific persona or setting the tone of your conversation. And it will be remembered throughout the conversation, so that every time you no need to tell that I'm talking about financial, I'm talking about healthcare. Okay, and second one is, that is pretty much straightforward, that is human message. And obviously here the role will be user. When the role is user, that particular message is called as human message. It is the user's input. Whatever your users types or ask, or whatever the file also they upload, they all comes under human message. I mean, it can be text, it can be image, it can be audio, it can be file. We discussed just now, right? Whatever, what kind of input for user role they can accept. Okay. Next is your AI message. This is where the role is related with assistant. Whenever your role is assistant, that particular message is called as AI message, and this is the response or the model response that you get back from the LLM. It can contain text, it can contain tool calls, and it will also contain all sorts of metadata. So whatever I'm told, right, the metadata present in the messages, so all those metadata will present here. So it will contain your model response, and this will also contain if you have any tool call, and also if you have any metadata, that also this AI message, in AI message you can find them. Okay, so in AI message whatever you can find, you can find a model response, you can find your tool call, or you can find your all the metadata. Then there is one important type which is called as AI message chunk. This is a new category. Okay, what is this? It is little bit of different than simple AI message. Obviously it links with the role assistant. It links when your model is streaming the responses in real time. Instead of you are waiting for the whole message to get generated by the model and then it come back to you, because any of the LLM, they generate token by token, they don't generate whole of the line at once, right? They don't generate whole the line at once, they generate every token at one time. They will generate one token, next time based on the previous token they will generate the next token, right? That's how most of the generative models or most of the today's LLM model works. Those are based on generative kind of models. One token, they will generate one token at each time, and based on the previous token the next token will be decided by the LLM. So while the LLM is generating one token at each time, you can, instead of you are waiting for the whole response to get generated and then see the message, you can see each token in real time. So that is what called as AI message chunk. This is all about streaming responses in real time. Once you generated all the responses, you can even append them with the plus symbol. So first time it will respond hi, then in next response it will respond I, in next it will respond am. Okay, then this. So at the end you can append them using the plus operator. Final type of message type is what we can call as tool message. Whenever your AI needs to use external tools, the results come back through tool message. Okay, so it doesn't link with any role, but whenever your AI model use external tools, their response come back through this tool message, and they will mostly be part of the AI message. Okay, so they will mostly be most of the time they will be part of the AI message. I mean, as I told, right? So inside AI message you something I'll call as tool call. So that was what I call as tool message. Storing your raw results, it also we can use this data for your downstream processing. Okay, I mean, you are not going to add this to a model context. Your model have a fixed length of tokens, right? So without adding without or making your model context very clutter, you can use this tool message every time you need. So finally you are making some conversations. You are not just asking one question and getting one response, that every model does. And for that you don't need these such complex types of messages and all, you just keep the text, you get the response. But when you are doing a conversations, you are asking follow-up question, you are doing 10 to 12 sets of conversations, then how you will structure all these messages? So the typical conversation flows like, you will have user, then assistant, then next user, then next assistant. But you forgot there is one more key message, that is the system message. So system message should always be placed in the top of the every conversation. I mean, this is the first time you asked a question and the assistant gave the response. Second time you asked a follow-up question and assistant gave the response. And third time you want to ask it, so it will be the user. So this should be a general conversation type. And this structure ensures the model always know what's happening. So that model knows This is the system message. I mean, this is how the model should behave, and these are the previous conversations already happens, and based on that, whatever question you are giving, the model will give you the response. Okay, let's start with the coding demo. So first of all, I have imported all the required libraries, and if you do not know what are the libraries are required, you can go to the requirement.txt file, or even I have everything in the requirements underscore temp.txt file with exact version of them. So this is come through the pip freeze command, and this is my normal pip requirement.txt file. So here I have imported all the files. So here I've listed out all the required libraries. Then I have loaded my environment variables. So if you are not really sure how to do this, you can watch out my previous videos where I have explained about the complete setup, how to do the complete setup to do the any of the LangChain code. Okay, then I have defined a one question, one really good question, reasoning question. I mean, just instead of just putting hi hello question, I just put a good question. Then I have initialized my chat Google generative AI model, and this is the model I'm using for now, Gemini 2.0 flashlight. So first let's discuss about different message types we have. So first the message we have is human message. So let's see how to define a human message. As I told, so we can pass the human message in two way. One is directly passing through the text. For example, I am directly passing it the text here. Directly I am passing the question, whichever I have. So I am passing the question, it will give us the response. So I got the response. And here you see, I got one more message that is called as AI message. So whenever I am asking any question to the model, the response it give back me is the AI message. So let me save it in result, then we can analyze the AI message in a better mode. So here we are seeing the two things, one is human message, another is the AI message. So let me print yeah. So inside AI message you have various kind of things. So first let's understand each thing. First is the content. So what is this content? Content gives the model response, exact model response this is giving about. And this is first way we are seeing how to pass human message, and along with that we are understanding how the AI message is also coming up from that. Then let's see what else are present. Let me just type type of result. Let's see, it is what is telling, it is a type of what's this type is LangChain core messages AI message. So this is a type of AI message which is defined inside the library LangChain core, which we have already installed it. Now let's see what else we have inside the result, or what inside the AI message. One is response metadata. I told there are different kinds of metadata available in AI message. So if you print this metadata, what you are able to see, you are able to see what is the model name you have provided. I mean, what the model name you have used, who is the provider of that model. Okay, any safety ratings or any prompt feedback you have. So these are the different kinds of metadata you have. Then one more metadata also you have is uses metadata. This is the response metadata. Then you have uses metadata, that is will told about the token uses. I mean, what are the input tokens, what are the output tokens, what is the total tokens. Okay, any tokens are being used in the cache format. So this is all about the token uses format. Then also I just told that there is one call format called as content blocks. So because I told that content block is standardized across all the messages, so here I am just providing the message in the form of question. But if you will see the content block, what is called as content blocks. So this content block is taking the question in a different format of the language. So it means whatever type you are giving the message or question to the LangChain or to the model, at the end or at the background, all are being processed in the form of content blocks. So you can provide in different format, you can provide through human message, you can provide through simple text which we just saw, or you can provide through specific provider format that we just discussed before this, right? Be it OpenAI specific format or Anthropic specific format, but at the end everyone is going via content blocks. This is the standardized across all the LLMs. You may have some ID. Oh, sorry. So this is the your REST message ID. So this is the message ID you are using it. Then one more thing we call as tool calls. We are not using any tool calls. We just use simple message. So there will be no tool calls here, but you can access whatever the tool calls has been called through this. So we have seen what are the different types of metadata associated with any of the normal LangChain message, and we saw how the first way how to provide a user question. This is directly provided in the text. Second, we'll see how to create a human message. For that, first I need to import message from langchain.core.messages, import human message. Okay, now let me define a human message. So what else you can give inside the human message? First of all, as I discussed, the first important thing here is the content, right? So in the content, let me pass the question, or you can pass your any question. I just predefined the question. So this is my human message. So let me do model dot invoke human message. Oh, oh, I need to provide it by a list of human message. Yeah. So yes, now also it is giving me AI message which has a content, and that has response metadata, that has ID, that has uses metadata, that has everything. Okay, it is also having tool call, but that will be empty. So this is the second way how we can pass the question to the LLM via human message. So here I am giving one human message. If you want, you can give multiple human message also. Let me create two more human messages. This is human message 2. Question as hi, and let me pass a list of human message. Okay, so I can pass a list of human messages as well, where to combining different human messages. So it not that you can only pass one question at a time. So this is, I mean, if you have various question at various places, you can combine them to a list, and you can provide them directly to the model. You no need to append all that into a single large block of string. Okay, now we just see where we're providing only content, but we can, but as I told, if you're providing multiple human messages, then it will be difficult afterwards to differentiate between which human message represents what. So for that, we can define some metadata to it. Okay, let me take this one. Provide some metadata or providing some unique identifiers. For example, I will provide this as the name, like person A, and I'll provide some ID to it, like message, let 1 2 3. Okay, this is my human message. Now I can pass that to also. Then this is the question I have asked. Then this is the questions, some name I provided. Person A has been asked. Second question has been given by person B. So you can assign person B to that. And if you want to extract the ID also, you can extract that as well. It has ID message 1 2 3. So this is with respect to human message. Now we will see how to provide the system message to it. So for that, for me, see, you can import in two ways. So either you can import initially, if you saw, I have imported from the LangChain code, that you can import, or you can import directly from the LangChain also. So here I have defined a system message that you are a senior Python developer with expertise in web frameworks and always provide code examples and expert reasoning. So I'm telling that you are acting like a Python developer who have the expertise in web frameworks, and you should always provide whatever the question I should ask. You should provide the response with some code example and the explanation to it. So now I gave some like how do I create REST API. Let me print it. Okay, see, um, let me just print it so that you can see it in a beautiful way. Scrollable, see, it is giving you with explanation, it is giving you with example of code, whatever I ask. So every time, so if I ask next question, right, if I will ask next question, I no need to tell this again and again that you are a Python developer and you have expertise. This I no need to tell every time. Once I define this system message, I can use it in the system message. Either next time, if you're calling it separately, you have to use it, or if you're doing a conversation, there you will see the importance of system message. You will pass it because we just saw the conversation structure, right? You have to pass it at the top once, and no need to tell that throughout your conversations. So this is all about system message. So now we will see what are the different ways we can pass this message to the model object. So the first way, the simplest way is to create the message object and then pass to the model for the invoking. So let me create a message object. So for that, I created a system message, then I created a human message. Or it is the same thing what we just saw now, right? I created a system message and I created a human message, then I am doing the invoking. So this is the first way, like creating the message object. These are the parts of the message objects. The second way we already saw, that is the through text prompt. I mean, directly you can do the model invoke and pass the question in the text format directly. So there is no need of creating any text, sorry, message object. So you are directly passing the text prompt. Okay, next we will see the third way, that is the message prompt. These are one of the alternative way where you can pass a list of message to the model by providing a list of message object. So in one message object, you can have your system prompt, human message, and your AI message or the response from the model. Then you can keep it for your next conversations. You can keep it ready for your next conversation. These are mostly helpful for while managing multi-turn conversations. For example, let me add this. So so here I am creating a AI message out of my own. So this message I have not received from anywhere. And yes, you can also create your own AI message, because I have the AI response from some other system. I can collect it, or I know this response which is collected from some data source is the AI response. So how to create AI message from that? So here is how you can create that. So here I created a list of message objects combining system message, human message, as well as AI message. So this is also kind of one of the way how to pass the messages to the LangChain model. The next way will be the dictionary format. I mean, with respect to different kind of providers, be it OpenAI or be it Anthropic, there are different format available in the dictionary way, where you will pass the role as well as you will pass the content. Let's see. Okay, now here if you see, I have created the whole messages of same system, user, and AI message in a dictionary format, where I have defined my role and I have defined my content. Okay, let's run it. Now let's proceed to the AI message chunks. I mean, if you remember, we have defined one more type of message we have already discussed, that is the AI message chunk that comes from the streaming response. Okay, let's see how it is. So here if you see, instead of I am doing model that invoke, I am doing model the stream, so that we can analyze how in real time any LLM generates the result. Let's see. Let me put one more uh, to distinguish star into 100, so that we can know when a next statement is getting printed. See, first it print let, then it print analyze, then it print the statements. A says B is liar, B says C is liar. So you can see every chunk it is printing one chunk at once. It is not print giving the whole response in single time. Okay, so it is giving you one chunk at one time, and based on that chunk it will generate the next chunk. So that's how general LLM works, generating token by token, generating chunk by chunk. Okay, and at the end I have the full message where, and we also saw right that we can append this streaming response using plus operator. So at the end I am adding this everything using the plus operator. I have the full message. So if I go and print the full message, I will get the complete result. See, this is full message, is not AI message, it is AI message chunk. Let me type. So here if you see the type of full message is AI message chunk because it is coming from the streaming. It is not coming from the model at invoke. Let's see about that because that is the only part pending. We have seen all types of messages. Only the part we have not seen till now is the how tool message works, or what happen when LLM invokes a tool method. Right. So tool messages are generally used to pass the result of a single tool execution back to the model, and it generates tool message objects directly. Okay, let's see one of the example of it. So if you see, I have created a LangChain message. I have created a AI message where I have created inside AI message. I have defined first the tool call. So I am creating a AI message where I am defining my tool call, because until unless, because if you go back and see inside AI message, we have the tool call, and when that tool call is going to invoke by the model, then the message what will got is called as tool message. This is coming after a model makes a tool call, because I told every time you are calling or invoking a model, either it will return a content, or it will return a response, or it will return the tool calls. So now the model is telling that I need to execute this tool, because tool call will not be executed by the LLM. It has to be executed in an external environment. But now model is telling that I need to call this tool. For example, I ask the question. Okay, I ask the question. We will see in detail how this whole tool calling work, because now I'm just showing about the tool message, how does tool message looks like and how it is working. But exactly how LLM decides which tool to call, or how to create a tool, how to define a tool, so those things we will cover in upcoming videos, where we'll see everything about the tool calling. Let me ask a question: what is the current weather in San Francisco? So the LLM will decide that I do not know the response of this question. So for that, I need to go and do the tool call, which is having the name of get weather, which will help me in getting the real time result or real time temperature of the San Francisco. So instead of returning the response, it returned me a tool call, telling that you need to execute this tool call. Now I will take this tool call and I will execute it. So let's assume when I executed this tool call means it may be a function, it may be a Python function, it may be a external APIs, it may be a web browsing, it can be anything. So let's assume I did the tool call and I got this result that the weather at the San Francisco is sunny with 72 degree Fahrenheit. Now this message is the result of a tool call. Now I need to convert that into a tool message, then only I can make it a part of the conversation, or because that is also a kind of message object. So understand the flow, how it is going. First you ask the question. Okay, first you ask the question. Second, LLM return the which tool it need to be get called, then you are calling that tool. Fourth, it is returning, you are getting the result from that tool, that is this one. Okay, next You are creating a tool message out of the result which you got from the tool calling, and then you are appending that tool message object to your conversations. Okay, sequential. Let me add here also. First, user asking question, LLM get invoked, or better right, model get invoked. After a model makes a tool call. Okay, then this is the result from the model. This is the result. This is the our result of tool call. Now here, creating tool message using tool call result. Okay, continuing conversation by adding tool message object. Okay, if I will print my message, you see, first I am telling that what is the weather in San Francisco. Then AI message is telling that there is a tool call which is of name get weather, and what is the result of that tool call? It is sunny 72 degree Fahrenheit. So you, then the model will take this and it will understand that the result of the San Francisco is 72 degree Fahrenheit, because here the location is San Francisco. So it is using the tool call, the result of the tool output in the form of tool message, combining that it is giving the result of this human with, because it doesn't know the result of San Francisco. For that, I am defining a tool call and I am giving the response of that tool call back to the model, which will help the LLM to give the result of the human question. This is a very simple example. We'll make it very clear in our next video when we'll do the tool calling.
Remember, messages have roles, content, and metadata, and they come in different types for different purposes. And LangChain standardizes everything across providers. That makes your life so much easy even when working with OpenAI, Gemini, or any other LLM. If you are building with LangChain, mastering messages is your first step to creating amazing AI applications. And if you find this helpful, please like, subscribe, and turn on the bell notification so you don't miss the next episode, where we'll go even deeper into LangChain's capabilities. Drop a comment below if you face any issues running this code, or if you want to see any specific use case in future. I will see you in the next video. Till then, keep learning, keep coding, and keep growing.